In this video, we're going to see the different standard forms of the equation of an ellipse. Now, we do have a couple of additional factors that go into it. So because of all of the additional factors, I wanted to make a couple of things uniform for what we're doing. So the first one is to represent the center of our ellipse. We're going to use an ordered pair for that. And the ordered pair that we're going to use is going to be the ordered pair HK. We did the same thing when we were talking about circles in the previous section. Additionally, we have two different orientations of the ellipse, but before we do so, I wanted to give you sort of the overarching what the equation of the ellipse looks like. So this can be derived through a great deal of algebra, but because the ellipse looks so very similar to the circle, it actually starts off in a very similar way to what we saw for the circle, where we'll see something squared plus something squared is equal to something else that's squared. However, because we don't have that nice uniform radius like we did for the circle, we're going to see a little bit of alteration in that regard. Now again, there is a proof for this that requires a great deal of algebra that we're not going to go through in this video. But we will see something squared over a squared plus something else squared over b squared is equal to 1. Now, what goes in here is going to be determined by the orientation. Now, for the record, the things that are being squared in here are the same things as what we saw for the circle. We'll see an x minus h, and we'll see a y minus k. Which one goes where is determined by the orientation of the ellipse. And by orientation, I mean the major axis. So for example, horizontal major axis. For a horizontal major axis, the general shape that was associated with this, and I'm really bad at drawing ellipses freehand, so you'll have to forgive me there. This is sort of what a horizontal major axis looks like for an ellipse. It would have its foci kind of like this. Now, in this regard, the distance A would be a horizontal distance, and the distance B would be a vertical distance. So associated with the A in standard form, I want to put our horizontal variable, and associated with the b in standard form, I want to put our vertical variable. Which means that for the horizontal major axis, I want to see the following. We can start the same way as before, with something squared over a squared plus something squared over b squared is equal to 1. Associated with the horizontal distance, I want my horizontal variable, that's x. But because of the shifted center, we're going to put an x minus h in there. Additionally, associated with the b variable, b is vertical now, so we'll put the vertical variable in there, y minus k. This is standard form for the equation of the ellipse with a horizontal major axis. Now, if we reverse that orientation and talk about a vertical major axis, again, not great at drawing these things freehand, but this is the general idea behind an ellipse with a vertical major axis. We'll put a couple of foci in there and a center. Now for the vertical major axis, this means now A is going to be your vertical variable or vertical distance, and B is going to be your horizontal distance. So once again, I want to associate the appropriate variables with the appropriate distances. So standard form, once again, is going to look like something squared over a squared plus something squared over b squared is equal to 1. This time, though, a is a vertical distance, I want to associate that with the vertical variable. That'll be y minus k. Then associated with the horizontal distance, we would want our horizontal variable. That'll be x minus h. In our next video, we'll actually go through some examples where we identify what is the center, what is the orientation, and what are our key distances, which will be a recurring theme in a lot of these videos.